Good evening, everyone. I first met Sam Feola when I first learned about Sam Feola when I was 9 years old. You see, in 1963, Elkins High School, my cousin was the star player, and they were undefeated. And in the sectional basketball tournament, Sam Feola and those Buchanan boys beat Elkins and knocked them out of the sectional tournament. We thought we were going to go to the state championship. And my mother, I can remember the whole night long talking about those blasted Feola boys. We are so happy to have you here for our Voices of Distinction series tonight, our first program. Sam Feola is obviously one of our most distinguished alumni. He has served this country with distinction, had a very interesting career flying as a helicopter pilot. Had a tremendous career with Raytheon, where he spent 20 years in Antarctica and really made us all proud with the work that he did with the science, major science project there on that continent. So tonight we're going to learn all about that. Sam has worked, been on campus for about 3 or 4 days now, entertaining and speaking to classes. He did 8 sessions today at Buchanan Middle School. That alone is worth a major round of applause if he survives. But we're so delighted to have Sam Feola, and it's my honor to introduce him.
I'm going to move up to the podium so I can see the screen better. Can you hear me okay? Okay. This gives me a little better vantage point to point things out on some of the slides that we're going to look at tonight. First of all, Pamela Balch is here tonight, and I want to give a special thanks to her for allowing me to come back and speaking to Wesleyan people. Thank you, Pam. And Bob and I have been trading emails, and he's been working his tail off for several months now trying to arrange all the classes I've been talking to. And we changed tactics a little bit this year. I asked him if I could speak a little bit more about project management and leadership because that really is my main business with Raytheon. The Antarctic program is one of the most important programs that we have in our country today from a science perspective, and I was fortunate enough to have led that program with Raytheon. It was a $1.9 billion program, and I had 3,000 employees, and we did a lot of fun things in helping our country's science to further itself. So with that, I'd like to start out here. I will say that after talking 8 periods today to 6th, 7th, and 8th graders has almost done me in. So if my voice wavers a little bit, it's because I've been talking for so long. I have a whole new admiration for teachers that can get up in a classroom and talk all day. I have to find my clicker. Okay, so what we're going to talk about is the United States Antarctic Program. And I have the presidential memorandum, and the reason is because this is a national program. It's blessed by and supported by the President of the United States. It was initially created when President Reagan, back in the 70s and 80s, he wrote a memorandum that said that the National Science Foundation in Washington was the lead agency to support the Antarctic program, and they can use anybody they want to support it, including the entire Department of Defense. So the Antarctic program today utilizes the U.S. Air Force, the New York Air National Guard, the Military Sea Lift Command for ships and fuel ships and cargo ships, and various other government agencies. So it really is a national program that we all belong to and have a part of. As well, since it is a national program, it means that every dime spent on it is our taxpayer dollars. So you can see, keep that in mind too, that this is our money at work. I'll put this up here because a lot of times when I talk about Antarctica, people come up to me and say, well, how are the polar bears up there? Well, first of all, there are no polar bears in Antarctica, and secondly, it's not up there, it's down there. So that was my first question of the middle school kids today, is where's Antarctica? And in almost every case, they said the bottom of the earth, which is exactly right. Up here in North America is where we are, of course, in the Arctic. But the Arctic is nothing more than floating ice on an ocean. The Antarctic is totally opposite of that. It is a land mass underneath, and it is one of our continents. And we're going to talk a little bit about some of the characteristics of it. But it is down there, and they have penguins as opposed to polar bears. Now, Antarctica, the South Pole, is 13,000 miles from Buchanan. And generally it takes about 5 to 7 days to get there by air. And when you leave the US, you fly out of Los Angeles primarily. And from Los Angeles, you'll fly all the way around to Auckland, New Zealand. It's a 13-hour flight across the Pacific from Los Angeles. And then we fly down to the South Island, to Christchurch, New Zealand, and there we switch from commercial flights to a military flight, generally an Air Force C-17, and we fly another 2,500 nautical miles down to McMurdo Station. So it's a long ways. And then from McMurdo, you can go on to South Pole on a different airplane. There are 3 stations in Antarctica that are US-based. One of them is McMurdo, the largest. South Pole is here, and the third is Palmer Station. There's no place to land at Palmer by airplane, so we have to take a ship over there from South America. So that's a little different route where they're coming down through Miami and down through Chile and getting on a ship here and then taking a 4-day passage across the Drake. And those of you that know geography a little bit, you've got the warm waters of the Pacific Ocean on this side meeting the cold waters of the Atlantic on this side, and they meet right here on the Drake Passage and create the worst water on Earth. It is not uncommon to have 100-foot seas in that area. And you don't want to be on a small little boat when you hit that kind of stuff. I've been across there 4 times. The worst I've had is about 40-foot seas for 4 days, but even that's enough to keep me in my bunk strapped in with a strap for those 4 days. It is not a pleasant way to go to Antarctica. This one I like because in the early days, Ernest Shackleton, and many of you have probably heard of Shackleton and all of his adventures, he was probably the greatest Antarctic explorer and the greatest leader of all of them. This was an advertisement he put in the paper in 1913 to try and attract some men to go down to Antarctica with him. And I think it tells a lot about a hazardous journey, small wages, bitter cold, long months of complete darkness, constant danger, safe return doubtful, honor and recognition in case of success. Now, that would be a heck of an advertisement to respond to, but a lot of men did in those days. Antarctica is the size of the United States, it's 1.5 times the size of the United States, so it's pretty large. You're talking about thousands of miles from one point to another. And there are no gas stations, there are no airfields except at South Pole and McMurdo. And it's a tough place to get around and do the exploring. These are just some of the mountains. It is the highest continent on Earth. A lot of these mountains are 12 to 16,000 feet. The highest peak is Mount Vincent Massif at 16,050 feet. But these mountains are like that everywhere. And underneath the ice, you probably have 6,000 or 8,000 feet of ice underneath these mountains as well. So it is the highest continent. It's also the driest continent. There's less than 2% humidity in Antarctica, and it is officially classified as a desert. And there's also one spot down there that they claim is the driest place on the face of the Earth. It's never seen any precipitation of any kind. It's also the coldest continent. I asked the kids in Buchanan what's the coldest they've ever gotten here in Buchanan, and some of them would say around 0. I think one kid said today about 10 below. And those kinds of temperatures I remember we used to get, but the coldest temperature on the face of the Earth was recorded at the Russian station at Vostok at minus 128.5 degrees Fahrenheit, 128 degrees below zero. Now at the South Pole, where we have our station and a number of people, the temperatures in the dead of winter, when it's all dark in July, can get down to about 105 below zero. Pretty darn cold. It actually warms up during the daylight. When the sun comes out and it warms up at South Pole, it'll warm up to about 45 below. It's also the windiest continent on Earth. Now, not all the time, but whenever you get a storm, you can be assured that it's probably going to be a doozy. There's a lot of hurricane force winds down here. I know that at McMurdo one year we had a 200 mile per hour windstorm that came through. And we have people that have to be out in that sometimes. We also have certain conditions. We call them condition 1, 2, and 3. And the worse the condition, the more you stay inside. And really, when it gets that bad, you probably have a condition 1 and everybody's supposed to stay inside. But there's also times, especially in the winter when it's dark, is that we will run ropes between buildings. And because if you're going to walk in the dark and the wind picks up and the blowing snow and you can't see the hand in front of your face, you're holding on to a rope and you keep walking with the rope in your hand until you get to where you're going to go. There have been times in the past when people have gotten lost going between buildings and walked off and frozen to death. Antarctica is also the emptiest continent on Earth. There are no people that live in Antarctica and all of its territory. There's a number of research stations, but no one actually lives there permanently. People go down for periods of time. In the U.S. program, most of our people will go down from October to February, and some of them will stay for a whole year, but very seldom. In fact, if any of our employees are down on the ice for a year and they want to stay working in Antarctica, we have to take them off the ice for at least 3 months so they can get their head back on straight, get used to civilization again, and get used to dealing with people except in a very harsh, remote, closed environment. And then if they pass a psychological test, we'll go ahead and send them back down again. But it's very tough working down there, even though today, because of internet, you can Skype, there's telephones, there's all these modern things that you can really communicate well with the outside world. Whereas back in the 70s, when I was in the Navy flying down there, that we would go 6 months and not even talk to anybody at home. So there's been a radical change, but there's still psychological things that you have to watch for. So there's one area near McMurdo Station that's actually called the Dry Valleys, and this is it. And this guy is on an 8,000-foot peak of a mountain overlooking this valley with all of these glaciers coming down. And the polar plateau is behind him and goes up to 11,000 feet. And then from that point on to South Pole, it's just nothing but snow and ice for 1,000 miles. Now, another unique thing about Antarctica is that you have one sunset a year and you have one sunrise a year. And in between, you have either 6 months of darkness or 6 months of daylight. This picture was taken at the South Pole. This is the South Pole station here. And you're familiar with the Aurora Borealis in the Arctic. This is the Australis Borealis at the South Pole. But 24 hours of darkness for 6 months. And then you have the daylight. And the sun comes up above the horizon and just kind of circles around. And you get a lot of work done when it's like that. We tend to work our people. We send people down there to work. They work 6 days a week, 9 hours a day. But honestly, most people will work 12, 14 hours and not really feel tired. When you have 24 hours of daylight, it really does a lot of things to your circadian rhythm. In fact, one of the biggest problems I think I always had was trying to make my room dark so I could sleep at night and create a dark environment. On the other hand, those people that stay down in the wintertime when it's dark all the time, they have a hard time making it daylight. They have certain kind of growing lights and things like that that are supposed to help you psychologically, but I don't think it works all that great. This picture is what we call the polar plateau. This is getting towards those dry valleys where that guy was standing on that little peak. That's all down in here. If you turned around from here and looked down, you would find that guy standing at the end of the valley. And so these are glaciers that are flowing off of the continent and over these probably 9,000 foot mountains. And then it forms into here and it becomes a river. And it's literally a river of ice. And there's thousands of these glaciers that are like that. So a little bit of history. When the United States, in fact the world, really got involved in research of science in Antarctica was in 1978 and 1957 and 58 when the International Geophysical Year was formed. And some of you are old enough to remember those days in the IGY when a lot of countries and scientists around the world got together and said, let's go there and really take an interest and start researching that place and finding out what we can find about our world. And the United States has been there ever since. It started out with 60 nations. There was a lot of international cooperation, even during the Cold War. I remember back in the 70s when I was down there with the Navy, we always had a couple of Russian scientists there with us. And we would send people from the US to the Russian stations, and they would just live and work with them all year long. So there are three main stations, like I said: McMurdo Station, which is our largest; South Pole Station, which is at the geographic center of the Earth; and Palmer Station, which is our smaller one. This is the one that's closer to South America and you need a ship to get to. And those are the three main places that we go. And then the scientists, and there are about 200 science projects every year. The scientists then go all over the place. It depends on what kind of study they're doing. A lot of them will be here in the western part of Antarctica. A lot of them are out here in the dry valleys where there's more exposed rock. Some of them will be in here, some of them will be here, some out here. They just go kind of all over the place, depending on what particular science discipline they're interested in. But it's a very large place. So I'll just speak for a second about the Antarctic Treaty, because this is important not only for Antarctica, but it's also important for what's happening in the north, in the Arctic region, with Russia, Canada, the US, Norway, Sweden. There's a lot of posturing by certain countries to position themselves for minerals resource exploration, and that's especially happening in the Arctic. It's also somewhat in the Antarctic. Back in the early exploring days, countries laid claim to certain parts of Antarctica, but when they decided to go do research down there, they created this treaty and they set aside all territorial claims, so no one owns Antarctica, and anybody, any nation, any person can go anywhere they want on the entire continent and build a station. They can put people there, they could do research, whatever. Nobody owns it. One of the kids asked me today, what laws do you follow? And the answer was, if you're at a US station, we follow US law, whether it's environmental law or civil law. The National Science Foundation has one representative every year that's based at McMurdo, and he's also a deputized US Marshal. So if there's ever a crime committed or there's a serious incident with a fight or something like that where somebody's seriously injured and it is a situation where somebody should be arrested, we have the ability to do that and hold them until the US Marshal from Hawaii comes down and takes them away. Some of the other things about the treaty: it was really designed for the peaceful pursuit of science, and the treaty actually says it prohibits nuclear and military action, and the emphasis on action, tactical military action. None of the countries do that, but the countries are allowed to use the military for logistical support, and the United States is the largest one that does that. We use the U.S. Air Force, the Air National Guard, the Navy, the Coast Guard, all kinds of military support for ships, airplanes, and that sort of thing. And that's allowed by the treaty. The other thing that a lot of people don't realize is, yes, we're there for science, but the United States is also there for physical presence, because someday they know this treaty is going to go away, and people are going to try and exercise their territorial claims. And there's enough minerals there, oil, gas, coal, you name it, it's there, that the United States wants to be in very prominent places when that day comes. And there are other nations that also feel the same way, but we are the only country that has a presence at the geographic South Pole. Now, the U.S. is very good about being the big guy on the continent. A lot of countries look up to us, a lot of countries come to us for assistance and help and support. And we're very good about acting responsibly, about being a real role model to the world, whether it's environmental or whatever. We always try to do the right thing. And as I mentioned, we follow U.S. laws. If I went to another Antarctic station like the New Zealanders have next to McMurdo, about 2 miles away, then I'd fall under New Zealand law at that point. This map just shows you a whole bunch of country stations. Now, most of them are temporary. Only the red ones have any permanence, where there's people that actually stay year-round. But they're rotated in and out every few months, 6 or 8 months. But you can see that there's a few of them. A lot of them are over here in the peninsula area because it's easy to get to. You can just get a ship, put a trailer on it, sail over to Antarctica, get off on the shore and put up a trailer and call yourself a station. Not so in the interior. This takes a lot of financial resources to do something like that, where you actually go inland. You either have to carry it inland or fly it inland. You have to build things, and then resupplying is pretty difficult to do. But a number of countries do that, and there's a lot of cooperation between everyone. So just a little bit about the National Science Foundation, again, the government agency responsible for the Antarctic program. They're funded about $360 million a year, and they use that $360 million to give X dollars to the civilian contractor that provides most of their support. They give X dollars to the U.S. Air Force to fly the C-17s. X dollars goes to the New York Air National Guard for their airplanes and people. There are several subcontractors like helicopters and various other things. And then they use money to give grants to the scientists also that go down to do research. And annually there's about 200 science projects. And there's probably about 3,000 people that go down there from the U.S. stations in any given year. And I mentioned earlier 3 main stations and 2 research ships, which I haven't shown you yet. And then there are many field camps. Some of them are close by that are helicopter supported within 100 miles or 200 miles. And then there's what we call the deep field camps, where you've got to get on an airplane and fly out 400 or 500 miles, 900 miles, 1,000 miles. Plane lands, it dumps people off, it dumps enough equipment and stuff to set up a camp, and then the plane goes away and maybe comes back 3 or 4 months later. So there's a lot of research that's done that way too. And then every year we have a fuel ship that comes in and a resupply ship, and I'll show you that in a second as well. So McMurdo Station is down here in the Ross Sea, and this is the area, South Pole up here and Palmer up there. This is what McMurdo looks like. It's really a small town. And everything that supports a small town here in the U.S. also supports this town of McMurdo in Antarctica. We've got, these are all dormitories that people live in. It's just like going to college. You've got a room with 2 or 3 bunks in it, so you have roommates, and 2 rooms share a common shower and toilet, and then each room has a sink in it. That's what these dorms are like. There's a huge building that serves as our cafeteria, our galley. We got a small retail store. We have 3 bars. 2 of them serve alcohol and 1 of them doesn't serve alcohol. We've got a band room where people can play instruments and put on shows and whatnot. We've got helicopter hangars. We've got facilities that maintain all of the vehicles that are down there, do all the maintenance on the vehicles. We've got a fire department for all of the structural fire. We also have fire department for the airplanes as well at the airfield. These are all fuel tanks. We've got a church. Just about everything. Well, there's a generator, a huge generator plant. There's a water plant because we're taking salt water and desalinating it into fresh water every day. And then there's a state-of-the-art sewage plant also. Now the other, I meant to show you one other thing here. This arrow points to the ocean. This is the ocean. This is where our airplanes land. We have 3 airfields that we build over the course of the season out on this ocean water. This is just another view of McMurdo, and I do it because I wanted to point out a couple extra things here. Right here is our large laboratory, and I have another picture of that in a second. It's probably one of the most sophisticated laboratories that the United States operates. But this arrow points to a hut that was built by Robert Falcon Scott in 1901 when he first ventured down to Antarctica to do some science and to go down as a British nation. And that hut is still there and has a lot of his stuff still inside. It's well preserved, and it is being, it's under the cognizance of the New Zealand government. They maintain that thing. This other arrow shows a big rectangular, it's actually an ice pier. Because a ship can come in here and it can drive up pretty close to this end of that inlet there, but there's no real harbor or anything to offload cargo onto. So we have to build it every year. And we literally will take water and put forms out and pump in water and let it freeze, and then we'll take cables and lace it with cables, pump more water and let it freeze, and you keep doing that, and through the course of the winter, this thing will get 7 or 8 feet deep, thick. And then when our ship comes down, it's strong enough to use as a dock to load and offload our ships. I think I have some pictures of that after a while. The other thing is kind of hard to see, but this thing here, that everything is above ground. Because this is volcanic rock and it's also permafrost, it's very, very difficult to dig any holes in it. So everything is laying on the surface. This is a water pipe as well as a sewage return pipe. And all of those are, it's just like up in Alaska and the Arctic, everything is pretty much above ground. Those are insulated pipes, and they have heat trace elements that run inside the pipe to keep them warm so that the water and the sewage and those things don't freeze. This is the laboratory I was speaking about. It's very sophisticated. There are 3 main pods of it. Each one of these pods has a particular discipline that the scientists use. For example, this is the aquarium. So at McMurdo, all the marine biologists and all of the people that do fish and various critters that are in the ocean, this is where they work out of. They've got holding tanks, they've got laboratories and things like that. Then you've got a wing that is all geology. So all the geologists have their own labs and their rock cutting tools and all those instruments and things like that. So there's